Hello, everyone. Again, my name is Kirsten Coronado, and this is my co-presenter, Nicholas Suzuki. First, we'd like to thank Ember Ignite for having us on and Jai for selecting us to present for you all today. This afternoon, we'll be making Fetch happen with our presentation, Under the Hood, the Fetch API. But for now, I'll pass it off to Nick to start us off.
Thank you, Kirsten. So the MDN web docs describe the Fetch API in the following way. It provides an interface for fetching resources, including across the network. It will seem familiar to anyone who has used the XML HTTP request, but this modern API provides a more powerful and flexible feature set. So before we dive into the Fetch API, we need to understand where it came from, and that is the XML HTTP request, or XHR. And in order to understand XHR, we first need to understand AJAX. So since JavaScript is a synchronous language, it will provide instructions from top to bottom. This means that running processing-intensive operations like retrieving information from a server will delay subsequent instructions from being executed until that operation is completed. When this happens, there will be a perceived slowness with the app, as the DOM would constantly need to pause while resources are retrieved. That is, unless a certain technique is implemented. And that technique is called AJAX, or Asynchronous JavaScript and XML.
More on AJAX. AJAX can be classified as a technique rather than a technology, with the goal of sending and retrieving data in the background that won't block code that is running synchronously. JavaScript schedules AJAX code to execute only when the request has been completed, allowing downstream code to execute. When response is received from the server on the front end, we're able to inject updated HTML onto the DOM, and we only need to update that portion of the page, not the entire page itself. Another benefit is it isolates errors. On a web page that had no AJAX, if a request errored out, everything after the error wouldn't render. So with asynchronous functionality, even if a query fails out, the rest of the web application will load. AJAX uses many different technologies to achieve its goal, like Axios, jQuery, and the Fetch API. However, AJAX came onto the scene in 1999 when the XHR object was first shipped. The XML HTTP request, or XHR, was first created by the developers of Outlook Web Access by Microsoft for the Microsoft Exchange Server 2000 in the late 90s. An interface called XML HTTP Request was developed and implemented into the second version of Microsoft XML Core Services, MS-XML, oh, that was a mouthful, which used the XHR concept. This version was shipped in 1999. XHR is an API in the form of an object whose methods transfer data between a web browser and a web server.
So here we have a real-life XML HTTP request that we made. Basically, what it does is that it makes a request to an API for a URL of a dog picture, and it renders that to a front end. Now we know that this is a pretty ugly code snippet, but we just wanted to illustrate how far JavaScript has come over the years. So the first thing we do in line 4 is we create a new XHR request and assign it to the variable XHTTP request. Then on line 7, we set up our functionality for our XHR after it's been sent with an event listener. Once the response is loaded, we check to see whether or not the status of the response is 200, which means that the response is okay or successful. And if it has any other status, we set up an error handler to log the error. So if the status is 200, we create an image element on line 14. Then on line 16, we assign the URL in our response object to the source of that image element, and we append our modified element to the DOM. And on line 26 is where we actually initialize our XHR with the open method. This has two parameters, the method that we're using, which is the GET request, and the URL we are making the request to. And on line 29, we identify the data type we are expecting back. And if we don't specify that the data will be a JSON, in this case, our functionality will try to process a string rather than an object, which will throw an error. And in line 31, we finally send out the XHR after the request has been formatted. As you can see, there is a ton of boilerplate needed and a lot of moving parts. And we have found ourselves at the open gates of callback hell, even though this is a pretty basic request. But thankfully, AJAX techniques have kept evolving over the years. For example, in 2006, jQuery, which is a JavaScript lightweight feature-rich library that has functionality that makes DOM manipulation, event handling, and AJAX simpler, burst onto the scene and became one of the most widely used libraries for development. However, one of the most influential updates to the JavaScript language happened in 2016, which was ES6. And one of the many amazing things this update brought were promises, which made the Fetch API possible.
The Fetch API, finally. So the Fetch API provides JavaScript an interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a global fetch method that provides an easy and logical way to fetch resources asynchronously across the network. But why fetch? Fetch allows you to make network requests similar to XML HTTP requests, XHR. And the main difference is that the Fetch API uses promises, as Nick mentioned, which enables a simpler and cleaner API, avoiding callback hell and having to remember the complex API of an XML HTTP request. On the left, you'll find a fetch request code snippet, while the right shows an XML HTTP request. We'll dive more into fetch in a moment, but for now, we'll make some simple visual observations. From the code snippet, we can see how much cleaner a fetch request looks, leaving less room for error when writing this type of request. In the fetch code, we see our promises in full effect, represented by the .then on line 2, as well as another at line 7. On line 12, the last line of the fetch request, we see our catch method. But before we dive deeper into what all of this means under the hood, we have to understand fetch's structure. Some basic concepts on fetch are as follows: the fetch method, headers, request, and response. Fetch is obviously the method utilized to fetch a resource. Headers represent the response and request headers, allowing us to query them and take different actions depending on the results. A request represents the resource request, and the response represents the response to a request. To understand what fetch does, we'll dive into the core difference between fetch, the Fetch API, and XHR, promises. In the following slides, we'll go through both promise chaining, a .then, and async await, granularly.
So after building that XHR code block, I had the pleasure of working with the Fetch API and building this code block. But to dive in, first in line 4, we invoke our fetch method, which sends our request to that same API that we used before. Since the default method for the Fetch API is a GET request, I don't have to specify the method type in this instance. This initial request is actually a promise that will either be fulfilled or rejected. At this point, the promise will only reject with a type error, meaning that the request was unable to be fulfilled, usually caused by a network error or cores being misconfigured. If a promise is rejected, the rejected case will go to our catch method on line 14, where we'll print out the error message. One thing to note is that if a request is fulfilled, but something goes wrong, such as the resource not being found, this would result in a response having a 404 status, but the promise won't be rejected. So we need additional functionality, like in line 8, where we have a condition to check if the response status is anything other than 200. So if the initial promise is fulfilled, like I mentioned, we would first check the status of our response in line 8. If the status is anything other than 200, we would enter the conditionals code block and throw an error with the status text from the response. If all goes well, that data that we received will usually be in JSON form, and we will then use the JSON method to parse the JSON and convert it into a JavaScript object, which is then passed to the next link of our promise chain. On line 13, we invoke the second .then method with the variable REST_obj, which is the resulting object from the previous .then method, and then we do the same DOM manipulation we did previously.
Now that we're refreshed on promises, we'll go into async await, a syntactic sugar for promises, effectively a wrapper that makes code execute more synchronously. Async await is used to work with promises. Granularly, it's a wrapper to restyle code and make promises easier to read and use. It makes synchronous code look more like synchronous or procedural code, which is much easier to understand. Await is exclusive to the async await functionality, which means it can only be used in async functions. Await is used for calling an async function and waits for it to resolve or reject. It blocks the execution of the code within the async function in which it's located. Some differences between a promise chain and async await is, unlike a promise, async await does not have any states. It returns a promise either resolved or rejected. Error handling in async await utilizes a try catch versus a then catch, as we use in promises. And in using async await, it makes it easier to read and understand the flow of the program as compared to promise chains. By now, I hope we can recognize that the block of code on the left is a fetch request utilizing promise chaining, while the right shows the same functionality wrapped in an async await. Visually, async await is easier to digest. The async denotes that the function will run asynchronously, and the awaits that follow will wait. The code pauses execution on those lines until the promises resolve. Async functions always return a promise. If the return value of an async function is not explicitly a promise, it will implicitly be wrapped in a promise. But here's a great question, a pretty big one. Promises or async await? Should I use promises or async await? And this is kind of a gated answer here, but really we can use either. It's entirely up to the developer. This tweet perfectly encompasses some misgivings that utilizing async await may have. It's convenient unless you need to handle errors, parallel tasks, timeouts, cancellations, intermediate status, multiple values emitted over time, or function coloring, as the tweet so nicely wraps. Async await is actually just syntax sugar built on top of promises, and it cannot be used with plain callbacks or node callbacks. Promises are more difficult in terms of readability, but arguably easier to iterate on when working with other developers versus debugging an async await problem. I'm personally not married to one or the other. It all depends on what I'm trying to accomplish that day. Here's the moment we've all been waiting for, the Fetch API walkthrough. This is the full block of code we'll be diving into with our walkthrough demo, representative of a GET request. But instead of talking about it, we'll jump right in.
All right, so like we had, that first line in the initial promise is of our promise chain. This fetch method will either be return a fulfilled promise or rejection. When a promise is fulfilled, the response will be passed to the next method in the promise chain as the argument of that method. Like we said before, this promise only rejects from the response being unable to be completed, usually from a network error like the server being down or a permissions error. In this case, the response will be sent to the catch method. And this is the second promise of our promise chain. We take the result from our first promise and use it as the argument of the callback in our .then method. The first thing we do in our callback function is we check whether the status of our response is 200. If it is not, we would throw an error with the reason that our information couldn't be retrieved. This is important because even though our fetch method will automatically handle any requests that don't complete, it will not reject HTTP errors like 404. So if the status is 200, we will continue past the condition and go to line 6, where we will use the JSON data from the previous promise as input, and the output will be a JavaScript object. This is a very important step because, as we can see, it turns our JSON data into an object that we can use. To illustrate, the snippet on the left is what JSON data looks like before it's parsed, and on the right, we have the object that is returned once we do parse our JSON data. And after we have parsed our JSON data, we will have an object that we can access. In line 8, we declare a constant called newImage and assign it an HTML image element. Then in line 9, we will access our REST object and assign the value of the message property, which is the URL, to the source attribute of our created element. Then in line 10, we append our newly made element to the DOM.
As we can see here, we have the cutest puppy rendering on the DOM, in turn showing up on the browser. When a promise is resolved, it gives us what we asked for. This photo of a dog is representative of the URL in our fetch request. In plain terms, if you ask for something in the fetch request and it's available, it will be served to you. The animated figure on the right is what happens under the hood when a promise is resolved. you'll notice that the catch is never invoked because the promise was resolved. But what happens when it isn't? Let's say theoretically that fetch request didn't work. When a promise is not resolved, the catch method is invoked, error handling anything that doesn't fulfill its promise. Catch is only used if the promise is rejected. In this case, the dotted highlighted line of code. An error will be thrown. This animated figure shows a similar under the hood functionality as the last, only this denotes a promise unfulfilled, resulting in the promise being rejected, and an error thrown wherever the catch method denotes.
All right, well, that's it from us. We hope you all learned as much about the Fetch API as we did diving into it. I just want to give Jai a big shout out for putting on this great conference, and to Jen Weber for helping us prepare a talk, and of course the Ember.js community for welcoming us. But please feel free to connect with Kirsten and myself, and we hope everyone has a wonderful rest of your day.